Hi everyone. So I'm going to talk you through the Midterm 2 study guide. So the Midterm 2 covers the t-tests as well as the one-way ANOVA. And there's um, there's a few concepts that are from earlier in well, the focus of this midterm is on the content since the last exam, but there is some material that was covered in the first portion of the class that is going to continue to come up. So again, I wouldn't call it cumulative, but there's some cumulative ideas and concepts that will keep coming up. And so I'll start off with those. There's a few concepts that you'll just want to be familiar with. The first is the difference between null and alternative hypothesis. Again, when you think about null hypothesis, it's a really unusual idea because it's actually the absence of a hypothesis, absence of a relationship. So null meaning none or zero. And so just think about it as there's no relationship. Now we're dealing with the t-test and the ANOVA. So we're actually talking, so when we talk about what is a relationship in these sections, we're talking about, is there a difference in the mean levels between the different groups? So does it matter what group you belong to? And when we talk about groups, we mean things like male, female. If we talk about if you have qualify for free lunch or you don't qualify for free lunch, you have all the different, groups that you could belong to, Republican, Democrat. And the question is, uh, are those two groups, male, female, um, Republican, Democrat, are they different on some other variable? The null hypothesis says, no, they're not different. On average, they're all the same. The alternative hypothesis is that on average, they are different, that there are differences in the group means. And so the alternative hypothesis is going to be that there is differences in the mean values. For retain and reject the null hypothesis, this one's just real straightforward. Just know if it's significant, you reject the null hypothesis. If it's not significant, you retain the null hypothesis. So that's the same, no changes there. Um, then I'm going to jump to type 1 error. So if you reject the null hypothesis, you might, well, you might be making the right decision. You might be saying there's a relationship there, and you may be right. But in statistics, you always acknowledge that you could be wrong. So if you reject the null hypothesis, the only type of error you could be making is a type 1 error. A type 1 error is a false positive. You think there's a relationship, but there's not. If you retain the null hypothesis, the only type of um, error you could be making is a type 2 error. You're making a false negative. So it could be true that there's no relationship between the two variables, but it could be that there is a relationship. You just don't see enough evidence to know that it's there. And so a type 2 error would be failing to find an effect that's really there. And so again, type 1 error, you find an effect that's not really there. Type 2 error is where you don't find an effect that really is. And again, I know that's kind of hard, but try to conceptually get it. And again, it's the same thing we covered in the first section of the course. The next thing to know is p-values. Well, this is real easy. It's just saying if it's less than 0.05, it's significant. And that's really the only thing that we mean there. And if it's 0.05 or greater, then it's not significant. Okay, so that's all review. Now, what is it that we learned in this section of the course? Well, again, we learned about the t-tests, and there's a group of t-tests. There's 3 of them. There's the one sample t-test, the dependent samples t-test, and then the independent samples t-test. So one of the things I want you to be able to do for this exam is actually identify, okay, here's a research question. what type of t-test do I use? Again, if you're doing research, it's not handed to you on a silver platter. Okay, here's what you need to do. Here's the type of statistical test you need to do. You have to, I mean, if you're in charge of the research study, you have to design it and then figure out how you're going to test whatever it is that you're looking at. And so basically I'm going to give you some research questions, and then you say, okay, oh, this is a one sample t-test. Oh, this is a dependent sample t-test. Oh, this is a independent sample t-test. Okay, so for a one sample t-test, the key thing you're looking for is there some value that I'm testing against? So you're going to take your sample and test it against some particular value. So if I wrote, oh, you want to see if it's this value is 65, well, that's most likely going to be a one sample t-test, because I'm giving you a specific test, a specific number, and saying, okay, is the sample different from this particular value? So that's a one sample t-test. The dependent samples t-test, what you're looking for is a sample where the participants have something in common with each other. Well, this is kind of the hardest one to unpack, because it can look a little bit different. So first off, if you see a pre-post, just assume that's going to be dependent samples t-test. But also, if you have a situation where the people are related to each other somehow, so a husband-wife combo, you're going to be more likely that it's going to be a dependent samples t-test in that situation. The reason being is the husbands and wives are related to each other. If you're asking them about their marital satisfaction, or their personality, it's more likely that they're have a similar marital satisfaction, similar personality. And so you couldn't just ignore those relationships, and so you have to take that into account, and that's why you would use the dependent samples t-test. The independent samples t-test is really the perhaps the most straightforward. It's, again, the bread and butter of experimental research. And what you're doing is you're looking to see if two groups are different from each other. And the reason, and what that does is you look to see if the means of the two groups are different. Okay, so again, hopefully that'll help you know when to use which t-test. Okay, so now to cover the assumptions of the t-test, and then, oops, I skipped over something here. First off, the null hypothesis and alternative hypothesis in t-test. The null hypothesis is always that the means are equal, that there's no differences in the mean group, in the means of the groups. So if it's a one sample t-test, the sample mean is the same as that value that you're testing it against. And the alternative hypothesis is that the means are different. The null hypothesis in the dependent sample t-test is that the dependent samples, the pre-post or the husband-wife, they are not different, that they are the same. And the alternative hypothesis is that they are different. The null hypothesis in the independent samples t-test is that the means of the two groups are not different, that they are equal. And the alternative hypothesis is that they are different, they're not equal. Now, you can have directional or non-directional hypotheses in t-tests. And so if you have a directional hypothesis, just know that you are only looking at the possibility of going in one direction. That you are saying, oh, this group is greater than this group. And it's a very specific one. You only do that if you are not interested in the alternative, in the other direction. And so usually in scientific research, the assumption is a non-directional hypothesis. And that's what SPSS gives you. If it gives you the p-value, assuming a non-directional hypothesis. And if you have a directional hypothesis, you have to divide that p-value by 2. So just remember that if you have a directional hypothesis for a t-test, you need to divide the p-value by 2. So if it was a p-value of 0.08, well, normally that would be not significant, but with a directional hypothesis, you divide it in 2, and it would be 0.04, so it would be significant. Okay, now a null hypothesis in a one-way ANOVA, that is that all the group means are equal, and that, or in other words, that there's no differences in the group means. And the alternative hypothesis is there is a difference in the group means, but they are not all equal. And again, for the one-way ANOVA, it could be just one group is different from the others, or it could be that they're all different from each other. Now, the reason why you need a post hoc test for a one-way ANOVA is for that very reason. Because it's just an overall test, it doesn't give you the specifics of what's going on. And that's why the post hoc tests are necessary. You have to look and see, well, why did I find a significant result? And you'd be curious about that. So you'd want to say, okay, what's going on here? Post hoc tests will help you identify which groups are different from which groups individually. But you only look at post hoc tests if the overall finding is significant. Okay, so see, the assumptions of the t-test and the ANOVA are actually the same. So the first two are pretty standard. They don't take much work. First one is random sampling, and so you just assume that it needs to be true random sampling, right? You cannot just pick out 5 Democrats, 5 Republicans, and say, oh, I think you guys are nice and you're mean. If it's not random sampling, you could potentially pick 5 people to basically make your point, and that's not going to be a valid finding. So the assumption of random sampling is really keeping you honest about are you actually generating are you getting a sample that is going to represent the population you're trying to say something about. The next assumption is the scale of measurement, and really it's just a check to make sure that you're running the right analysis. And so the t-test and the ANOVA, the independent variable is always nominal, and the dependent variable is always continuous, or scale, or interval, or ratio. And so you just need to verify that that's accurate. The group normality, this one is that the dependent variable needs to be normally distributed. So the dependent variable, you need to run the skewness and kurtosis and look and see, are both of those figures between -1 and 1. The quality of variance is also known as the homogeneity of variance, and that's that only applies to the independent sample t-test and the ANOVA. So it doesn't apply to the one-way ANOVA. It doesn't apply to the one sample t-test, and it doesn't apply to the dependent sample t-test. You need to run it if you're doing an independent samples t-test or if you're doing an ANOVA. In SPSS, it does it automatically for the independent samples t-test, and it's the Levene's test. The Levene's test, you don't want to be significant, because if it's significant, that means there is a lack of equality of variance. There's heterogeneity of variance, and so that's a bad thing. That's a violation of the assumption. Same with the one-way ANOVA. it doesn't do it automatically, but if you check that box that says homogeneity of variance test, then it's going to run the test. It's going to give you a Levene's statistic, and then it's going to give you a p-value. Same idea. If it's significant, that means you violated the assumption of equality of variance. Now, there's different things you do. If you violate the assumption of equality of variance with the independent samples t-test, well, you look for that line on the independent samples t-test. You look at that and go to the second line, and you find the which is that equal variances are not assumed. The top line says equal variance is assumed. The second line says equal variance is not assumed. And you just find the p-value for the independent samples t-test. That's all you have to do. If the equality of variance assumption is violated with the one-way ANOVA, you need to run the Welch test. Now, you don't need to know how to do that for this midterm. You just need to know that fact, that you would run the Welch test if the equality of variance assumption is violated. Okay, this is just asking you, okay, if I gave you the independent samples t-test SPSS output, can you interpret it? Can you find the equality of variance assumption and tell me if it was met or if it was violated? And can you find the result, if the result was significant, and should the null hypothesis be rejected? So again, that's just reading the output, knowing how to make the right decisions from it. And you don't actually have to run the SPSS for this multiple choice section. Okay, I'm going to stop there because that's all the multiple choice section. That's predominantly what you're studying for. I'm going to record just a little bit about the SPSS portion separately, but hopefully that'll help you get the main things that you're going to want to study for and be prepared for. So I'll pause there. Okay.